Everyone, my name is Jerome, and in this video, I'll demonstrate how to solve an initial value problem using the Euler method. I'll explain the method and show how to apply it in Excel, and then I'm going to compare with the exact solution for the error analysis. Okay, so what is Euler method? Euler method is a numerical technique used to approximate the solution of a first-order differential equation when it's difficult or impossible to solve exactly. And our goal here is to find the value of y when x equals to 1, given the differential equation being dy equal over dx equals to x squared plus 1 over y, having our initial value of y0 equals to 1. So let's look at the graph. The curved line you see is the true solution of this. And then the exact path that y follows, we start at the point of x0, y0 being over here. So this would be our 0, 1, which is on the, yeah. Then now, Euler's method helps us approximate the curve using straight lines. At each step, we find the slope of the curve at the current point. The slope basically tells us how steep the curve is, or in simple terms, how much y changes when x changes a little. We calculate the slope as rise over run. This being our next point. So going down here, we have our rise and our run. This will be our x0 and y0. And then we have, after we find our x1, y1, from then on, it will be x2, y2, and x3, y3, and so on. So step by step until we reach x equals to 1. By repeating this process, calculating the slope, moving a small step h, our h being the distance between our x1 and our x1, y1 and our x2, y2. This is our h. Our h being our step size which is between the x1, y1 and our x2, y2. Curved line is the true solution. Straight line is our Euler approximation. And the h is the step size that controls how far we move in each step. Now I'm going to show you how to set up Euler's method in Excel with x values in column B. And I'll start by putting the initial x value as 0 in cell B2. And in column C, we enter the initial y value, which is 1 in cell C2. And column D will calculate the slope using our differential equations. For B, I put in B2 plus 0.1. And then for y, which is on C, I put in C2 plus 0.1 times D2. And for our slope, I have to put in B3 to the power of 2 plus 1 over C3 over C2, sorry. Okay. Now, we're going to drag the formulas all the way until 10, which is the only way we can get to 1 for x. Which then gives our approximate value for y1 being 1.911375. So after getting our exact solution for the differential equation, I can plug this back in into the Excel on column E, where we'll come up to 1.914. Using the 1.914 and taking out from the y 1.911, we will have our error of 0.003479. This error tells us how we can choose a real method approximation to our true solution. And generally, using a smaller step size h will usually reduce this error. Thank you.